I'm Jeff Maxwell. We're talking about how to add OData to your .NET Core APIs. There was a talk by Jack Kinsey a couple of months ago here at the C# group, and he did an excellent job of talking how to write and deploy Web API using .NET Core. So if you haven't seen that, I'd definitely go back and watch that. It's on Twitch and YouTube, but that's where we're going to start, take his project and go ahead and add to it. So we're not going to start from a scratch program. And I'll take a look real quick at that. What he ended up with is a card game where you can have different cards. And he has a cards controller. He just mocks up some data. The card API here just has some different properties. And then when you run this, let me run this. And he goes in a lot more detail here. But then when you run I'm using Postman here to post against this API to get back all the cards, makes a call out, and it returns all the different cards to me. And so he went through kind of how to do that, add, delete, update for the API kind of out of the box. But what typically happens after you do a API, management or somebody comes to you and starts asking for more requests, or whoever's using your API wants more. They want to know, can I search across multiple fields? Can I, do a search across name or artist or different topics, text? They want to be able to get multiple order the columns. I want to order the data by the name, and then next I want to order by the artist, and the next I want to order by account or something like that. So they keep changing as you go through. They want to be able to just return one field. You're sending me back 150 fields. I just need one field. I'm creating a drop down or something like that on my web page. I just want that one field. Or, hey, I don't want the 100,000 records or 100 or 300 or 500 records out of your database. I just want them 20 at a time. I want to do something with paging. I want to be able to put it in a grid and do paging. Or I just want to return any related data. I have, in this example, we have a card, and then I added an artist class to it. So I want to return both the card and the artist together. I don't want to make two different calls. I don't want to make a call to the card and then go get the artist information for each person. I want to bring all that together. So how do we do that? I don't want to rewrite my API. I just want to turn it on, if you will. Microsoft created something called OData a long time ago, actually in 2007, and you can go to odata.org and read about it. And it was really to simplify the querying of REST and JSON data to get information back via the URL. So I'm passing queries on the URL, and then I get my information, only the information I want back from the server. So it does a lot of things. It helps me so I don't have to write all these different queries, and on the back end, it also will help me so I can just return the data that's relevant. So let's look at here's some of the defaults out of, I guess I could go full screen, but so you have select, order by, filter, top, skip, and expand. We'll go through each one of these a little bit. So the select, and you notice at the beginning of that, hopefully you can see that, is it's a dollar in front of it. So $select, $order by, $filter, $top, $skip, and $expand. So the select is just going to return what fields do you want to see. Out of all the fields you have, if you don't specify select, it returns everything. But if I want just a certain number of fields, I specify in the select. It's kind of like SQL, which fields that I want. Order by, just like it sounds, is ordering by whatever fields that you specify. Once again, comma delimited list. Filter, I can pass in equal filters, contains filters, those type of things in my query. Top and skip work together. So top is going to give you a number of records back. So if I say I want 10, it's going to return those 10 in that order. Then skip is for paging. So if I want top to be 10 and I have 100 records, I can say skip 2, which is going to skip to the 30, like 20 through 30. It's going to skip 2 pages of that. And then expand is a little interesting. You can actually expand any related data. So we'll take a look at that here in a second. So what do I need to do to turn all this on? And I don't want, like I said, I'm kind of a lazy coder, so I don't like to add a lot of code. So the first thing in the startup is I add, actually the very first thing, sorry, is I have to add this Microsoft ASP.NET Core OData. So I have to add that into my project and then restore the project. So you can do that with a .NET add package and then Microsoft.ASP.NET Core.OData. That'll add that package to your project. If you're using Visual Studio Professional or Community or something like that, you'll add that via NuGet package, and it'll add it here in your project. Then I have to tell my application I want to be able to use it. So in the configuration services, last time Jack was configuring an in-memory database, so this is used as just an in-memory database, but we're adding to the services add OData. So that makes it available. That basically turns it on, saying, okay, we have this package installed, now we want to be able to turn that on for our application. So you add this one line, and then below in the configuration, by default, when you create a ASP.NET Web API, it creates this line right here, add or app.use MVC. That tells it it's going to use an MVC project, so that's where you get your posts and gets and all of those type of things. Well, we want to extend that. We don't want to change it. We still want those things to work, but we want to extend that. So we changed that line into a little bit longer line. I broke it out a couple lines so it's hopefully a little easier to read. But we add the route builder, and then the first thing we do is enable dependency injection. So this allows us to, we're going to inject new features and functionality into our API calls. So we have to turn that on. Then you tell it which ones you want to turn on. You don't have to turn all of these on, but I'm turning on select, order by, filter, skip token, which is the skip, and then max top is top, and then expand. And I can default the max top to a certain number. So if I want a certain number of records to be returned, I can default it to that. So I turn that on, so that's the most code we write. And then for each API, if I go to the card API, I add this line right here that's highlighted. Hopefully you can see it. Enable query, open close parentheses. This is an attribute. So anywhere I want to turn on OData in my web API, I just add this one line. Okay? And that's all I do. So now what does that allow me to do? My code still works. Here's the original API. If I look at this select, let me zoom in, maybe you can see it a little bit better. If I zoom in here, that's as much as I can do it, I have the cards API. So I'm making a call, API/cards, and then I'm doing $, select equals name, type, artist, and text. So I'm just specifying which fields do I want returned. And when that executes, it just returns those specific fields. So already it's a lot easier than I can turn that on, and then they can go get whatever fields they want. If they want to see all of them, they don't specify any filter, and then they can specify which filters they want. And I use this a lot for when I'm doing a drop-down. I need a drop-down of companies, and I don't want the whole company's table. I just want an ID and a name to populate and drop down. So I can simply add this. I don't have to have a separate API call, and that works great. And you can combine these things together. So next, look at the order by. So I still have my same select with the name, type, artist, and text, but I did ampersand order by artist. So it still returns the same information, but it's now ordering the information by artist. Okay? So that orders it alphabetically. It's not doing first name, last name. It's just, since it's a string, it just starts at the first letter. So I can order that by anything I want. I could do name, and then I could do artist, then I could do type, I could do name. I can keep adding to that list of things that I want to order by. So it doesn't matter, and it handles it all, like I said, on the back end for me. Same thing with filtering. I can add a type of a filter. I might clear this out a little bit. Let me, yeah, so you can see I added filter rarity equals uncommon. You can do equal, greater than, less than, but the thing to note there is you can't use the actual equal symbol. You have to use EQ, because otherwise it would think it was a parameter. So if you're doing greater than, it's GT, less than, LT, those type of things. But you can compare numbers, you can compare strings, there's a contains. I can say, does this contain this value? So like a string, like a partial match. So that's really nice, because then I have my API, someone comes to me and says, hey, I need to be able to search by this field or do a partial search on this field. I just give them the query that they need to run. They can pass that usually from a JSON framework from the front end. So whether they're using the front end, it works great, works on mobile, however you want to make those calls. The top by itself is just going to return a certain number. I had 6 records, and when I added, this top, it's ampersand dollar top equals 3. Now it only returns 3 records for me. So you can specify how many records do I want to return. This is, like I said, used typically with skip, which is the next query I have. You usually do the top and skip, so you can do paging. So now I can do basically client server-side paging. If I have a grid and I'm returning 10 at a time, I do next. I'm still going to say I want 10, top 10, but I'm going to say skip equals 2. So I'm going to skip to the next record set. And once again, it handles it on the server. It's transferring less data back to the client for me. What I see a lot of people do is they'll return 1,000 or 10,000 records, and they'll put it in some type of JavaScript grid that has paging. Well, it's returning all 10,000 records and paging, so that can be inefficient, and they may never go past the first page. Right, so I'm increasing my bandwidth tremendously for that. So those are the main ones that we have, but what I really like is you can expand a query. So in the original application that Jack did, he had artist as just being a field. But a lot of times, maybe I want other attributes around the artist, so I want more data. So what I did is I added a model called artist, and it just has an ID, an email, age I just made up, and then a phone number. And then I said that an artist can have a collection of cards, and in the cards model, I said an artist, or a card has one artist. That may not be true, but in our case, it is. So in each model, I'm saying this card has one artist, and then a card can have multiple, or an artist can have multiple cards. I'm setting up those relationships with this artist info, and then the collection of cards. Then in the service, where is that? In the data context, there's one thing else you have to do. Setting up where I'm saying the card has one artist with many cards. And then I'm setting that entity, the artist, can have many cards with one artist. So set up that entity relationship. I think we've had several talks on our entity framework. And so that's how you relate those one-to-many and many-to-one relationships. Once that's set up, then I'm basically done. I don't have to change anything else on my code. It now has that relationship. So a card has a relationship of artists, and artist has a relationship of cards. So what I can come down here is I can do in this expand, I still have all the same information. I changed a little bit. I have select name, type, and text, and then I'm saying expand artist info. Artist info was that object saying the card has one artist called artist info. And by doing that, if I run this, it still returns the card. Let me see if I can scroll up a little bit here. Get a little more real estate. Yeah, I can't. But here's a card with the name, type, and text, but then it has a sub-object of artist info. And so it returns all the artist info to me. So I don't have to make 2 queries or multiple queries for each card. I can have as complex an entity model that I want. You can have orders and order details and all kinds of different things established in your entity model, and then return that all as one object. And it only returns it if you specify expand. So you're not getting it every time. Yes?
So does that account for the impossible problem with backend? So when any framework is taking in that use query functionality, right? And you're pushing for these nested pieces, when you send the query, or when EF sends the queries back, is it automatically accounting for that n plus 1 issue, or is it sending one for the initials and then one for every thereafter?
It actually queries it all on the server, and it does that relationship in the query. So, yes, if you're doing a database type query, then yeah, it may be more complex of how you're returning that. You'll probably have to have some type of a join between those and then return that data. But it is bringing it all back. I added those entities manually. It's just an in-memory database, so I just added some entities. But then someone may say, hey, I don't need the ID and the email and the age and the phone number of the artist. I just need their name. I'm just going to put their name. So you can still use subqueries inside of queries. So in this last one, I'm still selecting the name, type, and text from, what happened? Oh, from the card, and then I'm saying expand, and I'm saying expand artist info, and then in parentheses, I'm saying select name. So now I can return the artist info, but I can return what data I want out of artist info. So you can see now I have the artist info, and then I'm just returning one field from artist info. So you can get really complex with this, and I didn't change a single line of this backend API that Jack Kinsey wrote a couple of months ago. I just took what he had, I added some lines of code, and now I have a lot more functionality of what I can and can't do with that. Now, like you said, it's going to have to depend on how your entities are set up and how your relationships are set up, how performant those type of things are. I know that early on when Microsoft built this out, it did have some infinite loop issues where you had an item related to another item related to another item, so you could get it into a pretty ugly loop. But I think that that's kind of been worked out for a while now. So that's kind of one of the things where don't build out each individual API. Don't say, well, I need an API that sorts by name. Don't build that as a separate. And then I need one that sorts by first name, then last name, then company, and then, you know, this is a much simpler way to do it. Performance-wise, there's not a significant query hit because it's taking in that API, it's applying that filter on your data before it returns it. Any questions? Yes, sir.
So I know this one, that's right. I know this one's an in-memory table, and so it's not really a database, but if that were dropping back to the SQL database, for example, at what point is it actually filtering down the records? Like if I had 1 million record tables, bringing 1 million records back to the controller and then getting top 10?
Yeah, so you're probably going to change it out a little bit. So you don't have to do much on a single table. Right, it's when you're doing that expand. So your expand is probably going to be against some type of entity-related object, and it will do some of that query in the background. So it's going to bring that. It's the same type of thing as if you'd done include. So if you're writing an entity query and you include a sub-related table, it's the same hit that you were having before. That's what it's doing. That's what it's doing in behind the scenes. Yeah, so it's doing skips and takes, like you do on Entity Framework. It's doing the same thing. That's kind of how that's mapped. It's doing your order by. It's basically adding those predicates to your query. Right. So the way I would change this to make this a production type of an application, instead of here in the card controller where I'm just returning this card context, I would probably have a service and then do it there so I can do some caching and other things like that. Okay. If you have any questions, like I said, Jack Kinsey did a really good job of doing the intro of how to create a ASP.NET Core Web API from scratch and actually deploying it. I think he puts it in a Docker, he actually puts it in a Docker package and deploys it. Really good job there. And then, and all I did was I took a fork off of his GitHub. So his is Jack W. Kinsey /mtg-API. And then my GitHub is Jeff-Maxwell and then mtg-API. All of these slides, all of the code, all the examples are up there. And then I go step by step through what to add here on each one of those steps for each piece. But it's a few steps. Like I said, if you don't want to rewrite your APIs, this may be a way of adding some additional functionality. Okay? Any other questions? Thanks a lot.